visible to you, I suppose?
Yes, sir.
Yeah,
Yes,
okay, great. Yeah. So it's a very simple question they're asking. So there's a golf clubs company called the 19th Hole, and they sell golf clubs at outlets throughout the United States. Company knows that the demand for its club varies considerably with price. In the past year, demand at each price level is recorded in the table below. So this is what it looks like. So we have for 12 months the price which they charged and the corresponding demand in thousands. So first month price was $450 and the quantity demand was 4,500. That is 4,500 units, and so on and so forth. So you have the whole table there. And the company wants to estimate the relationship between demand and price, and then use this estimated relationship to answer the following questions. A couple of questions based on the relationship between price and demand. And assuming the unit cost of producing a set of clubs is $250 and the price must be a multiple of 100, multiple of 10, what price should the company charge to maximize its profit? How does the optimal price depending on the unit cost of producing a set of clubs? Okay, so please again open the Excel sheet.
Sir, while we are downloading the files, can I ask a question regarding the last slide that you had changes over time in the demand curve? So,
yeah, sure. Something on the slide, is it?
Yeah. I mean, there is one factor that is mentioned, the fourth one, changes over time. So,
okay.
I was just thinking of mobile phones. So at one point of time, they were very rare, and the cost of both the buying the handset and the billing plans was quite high. But now they are like very commonly used across India because of lower cost of both the telecom industry, from the telecom industry as well as the handset. So,
yeah. So, yes, please. Yeah.
So can we say that over a period of time, what was once a luxury has now become a necessity, and the demand would consequently change from elastic to inelastic?
Essentially, yeah, absolutely. There are multiple factors here. One is because the cost of production has come down because of mass production. That is one. You know, anything you produce in mass, you will be able to sell at a lower unit cost. Okay, technological improvements and availability of substitutes. More players entered into the market, so they made it competitive and they started pricing it differently. Like I said, price is not the only thing. There are other factors which also affect demand. So what you're saying is true. With time, clearly the price of mobile phones have come down significantly and substantially, and you would have noticed even the product itself has undergone a massive change in the last 15 years or so. From a basic, very clumsy looking device 15 to 18 years ago to rather very sleek, stylish device now. So absolutely, I agree with you. It's not only the price, but all the other technological factors, external factors, more players entering into the market, the supply side getting sort of crowded. I didn't talk about supply here. In fact, supply is another thing which influences demand and price. But again, we're just dealing with this. That is why I use about ceteris paribus, being all other things being equal. Earlier, perhaps there weren't very many people manufacturing. There was perhaps monopoly by Motorola and Nokia, the early entrants, and then gradually Apple entered, and then a slew of Chinese companies entered into the market, and then they have substantially brought down the price. So now so many factors which affect this. But like I said, because we're only looking at the sort of price thing, considering everything else equal. But your point is well taken.
All right, sir. Okay, you also clarified that it's probably best to look at holistically rather than just one factor.
Yeah, it's not one factor.
Yes. Not realistic. Yeah, it is good to understand the concept, but probably not realistic. So
exactly. Which is the reason always when you say economics, always use the word ceteris paribus. But
yeah, right.
The most interesting thing to study is price and quantity demanded. But of course, there are other factors which come into play. All right. So let's move on. I hope all of you have the. Yeah, yes, please. Yeah, I hope the Excel sheet is there with all of you. Company wants to establish a relationship between demand and price and uses. Okay. Any ideas, thoughts about how to proceed?
Sir, so I have created another column named estimate, and I've multiplied the price, corresponding price with the demand, and the most optimum value that I'm getting is
the highest value that you obtain.
Sir, 36,000 250
which month is that?
Fifth month, sir. 290 and 125.
Okay, that's a good start. I appreciate the way you're thinking. Any other inputs, please? How could we proceed with this?
Sir, as a first step, I have I've just started it, not calculated, but I'm thinking to calculate the average price. That would be, let's say, let's say, for an example, if the average price is A, then I would calculate the average price A, and that would be the sum of total price for the 12 months divided by 12. That is number of months.
Great.
So that would be 402.5. And then I'm calculating the demand. Sorry, average demand.
Okay.
So similarly, I'll be calculating the sum of demand from 1 to 12, and I'll divide by 12.
Okay, so basically you're saying that's one way of estimating the likely price and likelihood. Okay.
Yeah.
Good response. Okay, good approach. Any other inputs, please?
For me, I calculated the profit per month. So we have unit cost, we have the price and the demand. So I calculated the profit that could be generated per month.
How did you calculate the profit? Could you please explain?
Profit would be the price per unit minus the unit cost into the demand amount.
Okay. Yeah. Okay. Great. Yeah. Okay.
Yeah. And then I got the profit per month. There. So I'm just trying to plot a graph and kind of take a look at it.
Okay, interesting. Okay, so I really appreciate. I mean, people are thinking in very different ways with this concept. Okay. Yeah. Okay. Any other thoughts?
According to what Subham was mentioning, I'm getting 9th month as the most apt, because
I think Subham's is the most refined as of now, because it's also looking at profit straight away and saying, our objective is ultimately to maximize profit. So that's quite interesting.
We can calculate intercept and slope and.
Okay, Shivam, we can calculate intercept and slope. Okay, can you please be a little more elaborate?
Like we can calculate the slope from B2 to B13 and A2 to A13 and the intercept. And after that, we can use the formula intercept value plus slope value to the demand, the individual demands.
Okay, essentially saying you plot this and then you find a linear equation. Is that what you're saying, Shivam?
No, sir, not exactly the linear equation. After calculating the intercept value and slope value, like we can calculate profits for separate columns and use max function Excel.
Oh, okay, great. Yeah, that is even better solution. Yes, Puneet, you're raising your hands. Yes, please.
So I would build a scatter plot to start with and see what is and then add the trend line to see what is the relationship coming. There are various options. And see what is kind of coming closest to that, and then probably build further from that.
Great. Okay, I think Puneet has perhaps the most optimum solution. All your thinking is absolutely right. You're all thinking in the right direction. But I think Puneet has given us the most effective way to solve this problem. Basically, he says, create or build create a scatter plot rather. And look at the pattern and then see how we can take it forward, which is also some ways what Shivam has said. So let's try that. Do the scatter plot thing. So essentially what I'm trying to do is I'm taking the data here, price and demand, selecting all the data, and I'm saying insert.
So your screen is on the Word document.
It's still on the Word document. Is it okay? Sorry. I hope it's okay now.
Yes.
Okay, great. Yeah. So now we have the scatter. So we'll sort of try to plot the scatter plot. So scatter plot is nothing but you just sort of put each point of price. There will also be point for demand. So I'm selecting the entire data, and I'm going to insert, and I'm going to recommended charts.
So can we plot line chart here?
Absolutely. You can. You can. But let's look at, yeah, you can plot a line chart, but there are issues with line chart. I'll come to that, Simon. You will understand in a moment. Okay. So let's just stay with me for a bit. Yeah. Okay. So I am using the first option, the scatter plot. I'm saying okay, and I get the relationship between demand and price here. Okay. Now we need to see what is this relationship. For every price point, there is a demand. Let's try to estimate what that is. And let me sort of click on the plus button on the top right. And let me click on the option trend line. I'll have to move. Okay. I click on the option called trend line. And then a line appears. Right? A linear line appears. I hope you can see that. Okay. And now I need to, so this is actually a line which basically, this is a linear representation of the relationship between demand and price. And I want to further get the equation, mathematical equation for this. So therefore I say display on chart. So it's now displayed this equation on chart, which actually describes the relationship between X and Y, or a relationship between demand and price. Okay, please try this yourself. All I've done is inserted a scatter plot, and Excel is already automatically, yes, Satyam, please ask me.
I'm sorry, I was working on my Excel along with you. Where did we get this format trend line label from?
Yeah. Oh, I'm so happy. I'm absolutely delighted that you're asking me, you're stopping me, because I keep telling you, there are 35% of you are very comfortable with all these things. So if you don't stop me, I wouldn't know. Okay, great. So did you get this scatter plot, Satya?
Yes.
Okay, now on the top right, there is a plus sign. Okay, which is called chart elements.
Yeah.
Click on that, and then there is an option called trend line.
Yes, sir. Got it.
Okay, and then as you keep clicking it, and then you also find on the right there is another sort of
arrow,
sub column, arrow or whatever, arrow, there's an arrow, and that will again take you to give you another menu, whole host of options. And there is an option display, let's say it says linear, and then there is an option called display equation on chart. Did you find that?
From trend line, I got linear exponential, linear forecast, 2-period moving average, and more options.
No, linear. Then you go to more options.
Yeah.
Okay, and that's where you will find.
Oh, okay, got it.
There is an option. Click. Just have to click on it, and it says, and sort of line appears, and will also give you the equation.
Yeah, got it.
Okay, great. Yeah, others are comfortable, I suppose. No, yeah.
Thank you, sir.
Yeah. Okay, so essentially this is an equation of the form y is equal to mx plus c, and this is a linear estimation of the relationship between price and demand. Okay, so this is what is called as a linear model. Let's just try to sort of summarize what we have. So let me increase the size of this a little bit for visibility. Let's see where m is a slope. So let me put the slope here. Let's see here. M is minus 0.3546. M is minus 3. What was that? Sorry. Minus 0.354. Minus 0.3546. And the intercept is C is 211.31. 211.31. Okay. Now, so now we have a linear model. Basically, we now have a relationship between X and Y. Okay. Now let's try using this linear model. Let us see what does our linear model predict. Okay. So let me linear model. This is the actual price. This is the price. This is actual quantity demanded. But let us see what is it that our model will tell us. So it basically says the demand is going to be M, that is M multiplied by X. X here is a price, and you say plus C. So the linear model is actually predicting a demand of 51.74. Okay, now if I lock in the cells, if I drag it down, there will be an error because I've not locked the cells. So let's do that. Let's lock the values of M and C. So M is here. So I click on C38 and F4 dollar signs. Similarly, 13C39 F4. So both cells are blocked now. And now B22, I want it to sort of shift when I pull down. So let's see, I'll pull down the formula. Sorry. Oh no, I didn't change it. 1 second, please. F4, lock that, plus enter. Okay, committed that, and now drag it down. Okay. So this is the demand which is predicted by the linear model. I'm reducing.
Sorry, can you tell the formula once again that you have used for this linear model, sir?
Yeah, okay. So essentially, Aditya, what we're trying to do is, see, we have, I hope others are following. I think only, anyway, let me explain this. So essentially, what we're doing is, we've been given set of data points, price and demand. And we have just plotted it, what we call as a scatter plot. For every price, there is a demand. Okay, and along X, we have the demand. Along, along X, we have the price. Along Y, we have the demand. Okay, so essentially what we are doing is, we are trying to see what is the mathematical equation for this particular random dots, which are appearing on the screen. So we have tried to find what is called as a trend line, or a linear model, or a equation of the form y is equal to mx plus c, which is a straight line. So this straight line is obtained by minimizing the distances between each of these points, and what is called a best fit line, an optimized line which best represents each of these points. Okay, right. This is a line which we can automatically create using the function which I was just explaining to you. Were you around? Yes. Aditya, have you just joined?
Yeah, that part is clear. I'm just looking for the last part where we were calculating. Okay. Right. So what formula are we using there?
Yeah, so you're comfortable with the idea of this?
Yeah, this one I'm clear. Yes.
Y is equal to mx plus c. You understand what y is equal to mx plus c? Yes. It's actually an equation for a straight line. And because our model is a linear model, this straight line is represented by this equation, y is equal to mx plus c. And that we have found the values of m, which is the slope, and c, which is a constant or intercept. Okay, basic mathematical concepts. So I am using this particular equation here, and we find that the original demand is 45 units, 103 units, 49 units, and so on. However, when I use my model, which is the linear model which I've just generated, and I've obtained those values by using the formula y is equal to mx plus c. You can see it here.
Okay.
Which is, I've clicked on the cell. So what you can see is, see, first I've entered C38. C38 refers to M. Okay, into X. X is a price. Price is B22. Y is equal to MX plus C. C is a constant. That is 211.31.
Okay, got it.
All right. So Y is equal to MX plus C. That is the formula I've entered there. And this is the model which is predicted by the linear demand function. Linear demand curve. Okay. So Y is equal to MX plus C. And when the price is 450, the model predicts that the demand is going to be this, and I click, I get the answer for that, which is 51.7 in hundreds. So which is essentially 5,170. Is that okay, Aditya?
Yes, yes, that's
all
fine.
I did is Yeah, all I did is I pulled the formula down, which means I randomly click somewhere here. I can see the same formula is used here, y is equal to mx plus c. So in this instance, y is given by mx, m is your value, which is picked up from cell C38 into x. X, of course, is 430. And that is the beauty of dragging the formula, plus c, the intercept. Okay, I hope.
Yes, yes,
I hope all are
follow.
comfortable. I'm so happy that you people are, sort of stopping and asking. You're okay, fine. How about the others? Any other issues? Anybody else?
I just want to check.
Okay.
Sorry to interrupt, sir. I just want to check on one more thing. When we log the formula, can you please elaborate it or kind of just hover over that particular cell?
Yeah. So essentially, what happens is, Shivam, when you lock the formula, you use a $ in front of each of those reference. Okay. So each cell is identified by an alphabet and a number, like say A25, C34, and so on and so forth. So if you insert a $ before C and before 38, that cell gets locked. This is called as fixed referencing in Excel. By default, Excel uses what is called as relative referencing, which means whenever I use a formula and if I drag it down, now see, for instance, 450 is something which I have not locked. So it is trying to reference 450, and how Excel reads it is, okay, pick up the cell which is 2 cells to the left of this formula where I'm using the formula. So in this particular cell where I have inserted the formula B22, it's picking up 2 cells to the left. Now again, if I copy the formula somewhere down, it will repeat the same thing. Say for instance, I'm randomly clicking here. It is picking the value B28. Essentially, it is picking cells two cells to its left. Okay. However, if I lock it, you will notice that it will refer to that all the time. That is called absolute referencing. Okay, so let me just, for the benefit of Shubham, of Satyam, Ravi, I'm seeing you. I'll just come back to you. So let me sort of remove this referencing. So what I'll do is F4. Okay, if I keep clicking F4, the referencing goes away. Okay, the referencing is gone. Okay, if this is the formula, sorry. I should remove the referencing. I can either click on that or can delete it. Okay, if the referencing goes away, you will notice, see, now when I click here, this is trying to pull the values, sorry, it's trying to pull the values from this cell, that is B23, which I'm okay with. It's also trying to pull values from C. Instead of M, it is actually pulling up from C. I hope it's visible. Is it? See?
Yeah, it is.
Okay, it's trying to pull those values 2 cells below. Correct. If I click somewhere here, let's say for instance, if I click here, now see what is happening. Every time I move 1 cell down, it is trying to find that related to this, whatever relationship exists, it's trying to keep maintain the same relationship. That is why it's called relative referencing. Okay, so if you click on the next cell, you will find that Excel is searching for a value in that particular cell, but there isn't any. That is why it's giving you error.
Yeah.
So we don't want the relative referencing to kick in. So we want to lock those cells, which is what is called as absolute referencing. And to do that, we insert a $ cell before the cells. Okay, so how we achieve that is, see, we come to the first formula. I want relative referencing for 450 for my X value. Price is X here. But for MX and for M and C, I need absolute referencing. I want every time the formula to refer to M and C. All right?
Yeah.
Okay, so how I do that is, again, insert a $. Let's say a $. And enter. Now, if I drag the formula down, you will notice that B23 I have not locked. So when I drag the formula, relative referencing sort of applies for B23. However, For the other two cells, you have what is called as absolute referencing, which means it will always look for M and C in those particular cells which I've locked using dollar signs.
Got it.
Is that okay? All right.
Yes,
Yes, you had something.
Sir, you actually answered it. I noticed you were using F4 for locking the cells.
Yes. So F4, what happens is every time you use F4, first time
it cycles.
It locks one, then the next one. Like, see, there are three ways. First is you can lock the row, you can lock the column, or you can lock the cell absolutely. I mean, it's one particular place. So we have used this, mixed referencing also in some of the earlier multiplication classes and all that. So one way you want it to shift, the other way you want it to stay, and vertically you want it to stay, and horizontally you want it to move, and all of those kinds of things. So you can actually, the shortcut for that is F4. Keep clicking F4, you will get. Okay, fine.
Yes.
So the linear model essentially is the equation which I have generated from Excel, simply what is called as a trend line in Excel, and I picked up that value, and this is my linear model, and this is the predicted value using our model. Now let us actually calculate if this linear model is a good fit. Let's see how good this model is. Okay, but before coming to that, let us also look at, so is linear model the best model? Can you think about any other way in which, do you really think this particular, let's say, set of dots is best represented by this particular line? Yeah, Kiran?
We can find R square value, right? For checking the goodness.
No, there is no reason to find. We are only interested in if there is a relationship between X and Y. We are not looking at R square. I mean, why would we look at R square?
So exponential model.
Yes, Sayan. Yes. So, which means this is not the only way in which you can fit these dots. Okay, we can also look at, let's say, other lines which would probably be a better fit for this. And like Sayan says, we could perhaps think about what is called as an exponential model. Okay, let's try doing that. So this is, say, demand, and let's call this linear model. Demand versus price. Okay, so I'm going to put this aside for a bit, drag this down, and let's look at what science said. Let's also look at an alternative model. Let's not entirely rely on the linear model. Let's see if we can think about other models to find a fit here. So now again, oops, sorry. Okay, so now again, I'm trying to repeat this process. Let me again click on all the data points. I go to insert, and I go to recommended charts, and I go to scatter plot. I say okay. I see the same thing, the same scatter plot is back here. And now science says we should try an exponential fit. Okay, so let's try doing that. Now I click on this plus button, and I say trend line. Click on the trend line. This time, instead of linear, I click on exponential. Okay, and you find a different line appears. Now I want equation for that. Okay, I want the exponential model, and I want equation. I say display equation on chart, click on that, and I get the equation for this. It gets displayed here, and I'm going to make it bigger. I select it, and okay. Right. So please attempt it yourself. Please see if you're able to get the equation for the exponential model.
So I'm getting both the linear and exponential line, like maybe.
No, please click one unchecked. don't click on both, because when you drop down on the far right, I've only got a thumbs up from Deepak. Others, I suppose I'm just giving some time. Please get the equation for the exponential model. Yeah, okay, Aditya's got it. So Sujandev, yeah, all of you are okay. Aditya, comfortable? Others are okay? Ravi, Shivam. Okay, all of you have got it. Okay. Okay, more. Okay, all of you are comfortable. Let's move on. Yeah. Okay, great. Fine. So you have the exponential model now. So exponential is of the form y is equal to a e raised to bx. Okay, let's rename it. Y is equal to a e raised to bx. So we have a value of a here, we have a value of b here. Let's determine what those values are. A is 466.51, 466.51, and b is minus 0.005, minus 0.005. Okay, so we have the exponential model. Now we use this exponential model and estimate the demand. As earlier, say y is equal to sorry, a e raised to bx. A, I'm referring to 466.51 multiplied by e, that is exponential. There is a function called exp, exponential raised to b multiplied by x. X we pick up from here. And I close the bracket. So I get the value for demand generated forecast using the exponential model. Okay, then let me lock in these cells. That is for value of A and B. So click on that. F4, it's locked. I want H39 to float. B22, no, sorry, H39 price. Okay, so I want H39 also to be locked. F4 and B22 to float. Okay, click on it, drag it down. So I've got a different model here. Okay, all of you comfortable so far? Please try these yourselves. Yes, Aditya is comfortable. Just giving a couple of minutes for others. Please estimate the demand using the exponential model also. See if you're getting the other values. Please give a thumbs up. Yeah, Ravi is also okay. Srujan Dev, Sayan. Okay, Shivam, are you okay?
Yes, sir. I'm
okay.
fine.
Great. Okay. No, actually, I was thinking about Satyam. Yeah, Satyam.
Yes, sir.
Okay.
I did not get the value. Can you please show me the formula once again, please?
Okay. Okay. Did you get the curve right?
Yeah. I got the curve. I got the values.
Equation.
Yeah, I'm just putting the values in the equation.
Okay. So this is the equation. Y is equal to a e raised to bx. Okay, so this one y is equal to 466.51 e raised to minus 0.05x.
Yeah.
Okay, that is typically of the form y is equal to a e raised to bx. So the value of a is 466.51, which is here, and value of b is minus 0.05. So I capture those values here and then use it in my model and get these values.
Yes, that is okay. Okay.
Yeah.
Yeah, I'll try. Yeah.
Yeah. Okay. Great. Okay. So you have the linear model. You have the exponential model. Now let's look at let's say one more model. Okay. Now, because I think Sayan has given us a hint, let's try to see if we can fit it with a better model, even better model. Let's try. Yeah, yes, please. Somebody is saying I can't figure out who is speaking. Okay, great. Yeah, fine. So let's try yet another model. Let's perhaps try a power model. Again, I pick up all this data. I go to scatter plot. Say okay. And this time I go for more options. And I say power. And drag it down and ask Excel to display the equation on the chart. And drag the equation to a more convenient place.
So what is power?
So that is this equation of the form y is equal to a raised to bx. Equation of the form x raised to b. Sorry, a x raised to b. Okay, so you can see this equation here. Y is equal to a x raised to b. So I need to figure out the values of a and b. Is that okay? I don't know who asked the question. I couldn't see. Yeah.
Shine.
Yeah, Shine. Yeah, okay.
So what is the difference between exponential and power?
Only the equation difference. Exponential is of the form a e raised to bx, and the other one is y is equal to a x raised to b.
Okay.
Okay, you will get different values for a and b.
So is quadratic a better fit, or this one is a better fit?
That we'll figure out. I mean, we need to see which is the better one. Let's see which is the better fit. Okay, that is the reason I introduced one more. Okay, so we have the linear and we have the exponential. We also have the power. Okay, let's see which if the power is better, exponential is better, or linear is better. Okay, so again we get the equation for this. So let me just try to get the value because it's a really large value, 6e plus 0.6x. So I'm trying to figure out this particular value. That's 6e plus 0.6 because we read it in our calculations. So let's see how we can format it. See, this a value is a rather large value, which is why Excel is displaying it as 6e plus 0.6x. But I want a more, let's say, I want that number to be displayed as it is. Okay, what is what I'm trying to do. I'm just trying to figure out what that exact value is. Okay, select data, select trend line, data series. Okay, let's try that.
So there may be a limitation. I think what it is saying is 6 followed by 6 zeros.
Exactly, exactly. But I need to get that exact value, Deepak. It's possible.
Yeah,
it's formatting. Yeah.
So sometimes in some parts of Excel, it just displays it like this. So
no, we should be able to format it the right way and get it. I mean,
so we can extract the data.
Exactly. That's what I'm trying to do.
Yes, we can.
Yes, I'm trying to do that precisely. Because it is important. No, what we're doing is because even if there is a decimal error, our model will change. So I'm trying to get that exact value.
So there is something number in the third.
Where is that? Yeah, option. There are too many options in Excel. Sometimes it becomes font, select data, edit, format data series trend line. Okay, there is an option called format trend line label. Yes. Okay. Right click format. Okay, and then number is category general. So I'll make it number here. And I say click on this. I should get it now. No. Wait, hang on. So I'm just trying to repeat the exercise once again. Okay. I've deleted everything. Okay, so I just have the scatter plot now. Click on plus button right on the top. Go to trend lines. Sorry, I go to trend line. Click on the button. I go to more options. I say power, and I say display equation on chart. Okay, I have the equation displayed here, and I right click. I say format trend line label, and I come to this general, and I say number. Yeah, now you can see the number has changed. It has become 5871064. Okay, so that is what I wanted. I wanted the exact number. Earlier it was giving me an sort of approximation 6 into 10 raised to 6, which is what I wanted. I wanted the exact number. So now I've got it. And I hope it's visible. I'll make it bigger now. Okay, so now, like I said, a power equation is of the form y is equal to a x raised to b. Let's put that down. The power model y is equal to a x raised to b, and a is 5871064. 5871064. 5871064.2. Let's not lose the accuracy. And x raised to b. B is minus 1.91. B is equal to minus 1.91. Okay, so people are comfortable so far. So it's just a third equation which I have picked up from Excel. So please give me a thumbs up. Okay, people are still working on. Okay, only Satyam and Srivatsam and Srijan, Puneet.
Sir, I'm not getting that value.
Okay, yeah. So essentially, you know what Excel does is, because it's a large number, what it has done is 6 into 10 raised to 6. So we need to get the exact value. What we need to do is we had formatted as number, and I have demonstrated it a second time. So click. Okay. Okay. I'm sorry about it. I had a brief power outage. Am I audible, visible now?
Yes, sir.
Okay, great. Yeah, sorry about that. Okay. So who was asking me? Om Prakash was asking something. Yes, Om, tell me.
Yes, sir. I was asking that I just click on trend value to change that format on the label.
Okay.
But I didn't get numbers.
So, okay, no, you click on this, and you have to also click on, see, wait, let me share. I've not shared the screen. 1 second. Actually, when you click on this, there's a trend line option, and on the far right of it, there is a little bit, there's a small triangle. Click on it, and then you say more options. Okay, along with the power, okay, you click on power, then you also click on this option below saying display equation on chart. You have to click on that. Only then will you get the equation displayed on your chart.
No, sir, I'm getting display on equation on the chart, but I didn't get this number 58710.
Okay, yeah. It will be like something like 6e plus 10, something of that sort, right?
Yes, sir. Yes, sir.
So basically, what Excel is trying to do is Excel is trying to sort of, you know, put it in a different format, especially when it's a large number. It will try to abbreviate. So let's try to get the actual number. That's what I was trying to explain. So you click on this. Okay, click on, right click on it, say format trend line label. Click on that, and then click on number. This option earlier, this was general, that you change it to number. Okay, if I make it general, it will look again 6e plus 06. I hope you can see the change. I'm really sorry about it. I don't know what is going wrong today. Yeah, okay. Yes, so where was Om? Om, you're okay? Did you get it?
Yes. Yes, sir. Yes, sir.
Okay, so essentially, see, this particular thing, you have to format it. And because it's a large number, Excel is trying to format, by default, it is going to put it as a general format. That you have to convert it into number. When you do it, you will get this. You can see the transformation. So when I put it as general, it shows us 6e plus 06x, 6e plus 06, that is 6 into 10 raised to 6. That is what it means. 6 into 10 raised to 6. Okay. So to get the exact value, click on this and say number. It will tell you it is 58,071,064. Okay, that is 5.8 into 10 raised to 6. That is what it was trying to say. 5.8 into 10 raised to 6, approximated to 6 into 10 raised to 6. That's why it was showing it as 6C6. Go back to that notation again. See, showing us 6C06. What it means is 6 into 10 raised to 6. Okay, we will want it in number because we want to be more accurate. Okay, all right. So we now have the three models. Now using this equation, let us build the power model. So did we get the equation right? Okay, the power model is here. Y is equal to ax raised to b. A is 58,71064. B is 1.91. I hope those numbers are right. 50,
Sir,
yeah.
B is
Yes.
negative value, right?
B is negative.
B
Yeah,
has
minus 1.9. Absolutely. Yeah. Thank you. Thank you. Yeah, I think minus 1.91. That's correct. Okay. This minus. Okay. 58,710.
And sir, I think so. You missed point 2. A is in last point 2 you missed.
Point 2. Okay, let's see. Equate. Let's put that one. Yeah, it's there. It's point 2 is there, but it's just that not formatted.
Okay.
See, you see the formula bar. You will see that it's 0.2. 58,71064.2. It's just that. Okay, if you want me to display. Okay. Okay, great. Is that okay? Fine. So now let's find.
Thank you, sir.
Yeah. Yes. Something else. Yes, Om, tell me.
No, sir, it's fine. It's fine.
Yeah. Okay. Yeah. So now let's look at the power model. And the equation is y is equal to a x raised to b. It's equal to a. I'm picking up the value here. Multiply x is here, price raised to b. Let me lock in a and b. F4 b F4, enter, and now I have all the values for predicted by the power model also. All of you comfortable so far?
Sorry, can you hover on the formula once again, please?
Formula, sure. Yeah. So essentially, I've captured the value of power model. So the equation for the power model is y is equal to ax raised to b. You don't have to memorize it. Excel will tell you. It is written here y is equal to a x raised to b. That is 58,71064 x raised to some number a x raised to b. So don't bother with really having to memorize these things. So now the power model is y a x raised to b. We have the coefficients. A is equal to this value which I picked up from the equation. B again I picked up from the equation, and then I'm using that formula which is here, which is y is equal to a, which is locked at this. Into x.
Got it.
X is the price raised to that caret symbol, and then b. Okay. Then once I lock the required cells and drag the formula down, and I get these values. So I'm assuming people are comfortable till now. Please give me a thumbs up. Let me just see if all are okay. So far, okay. Puneet, okay. Satyam, Om Prakash, Yavi, Kiran, Shivam, okay. Aditya. How about the others? Abhinash, Sameer, Anushri, Manish, Kiran. Others around? Kiran? Okay, Sameer, Kiran. Okay, Anushri. Okay, so I'm just saying it because I'm calling out your name, or I hope you're really comfortable. Okay, great. Okay, if you've got it, let's move on.
Sir,
yeah, Manish, tell me. Yeah.
Sir, how you locking the cells are using the F4? But
F4 is a shortcut key.
Locking.
Yeah, suppose you say sometimes if your keyboard, sometimes you may have to press on the function F4, or you may have to, it depends on the keyboard, but the function, if you just click on a cell and click on F4, you will find the dollar signs appearing automatically. So you, in your keyboard, you may have to use the function key if it's a combo keyboard. So please try that also. F function plus F4 or simply try F4. You'll figure it out, trial and error. So then the dollar signs will appear. It's a shortcut, or you can manually enter dollar before the referencing. Okay. Right. So now we have 3 models. Now any comments, inputs on how can we, which is a superior model now? Which of these models do we choose?
So as it's an elastic product, the demand varies with it's a general understanding. So
Okay.
the exponential or the power one may be a better comparatively to a linear one.
No, it has nothing to do with whether it is elastic or inelastic. If we are using a particular model, whether it's linear, power, or exponential, there has to be some criteria. What criteria? Nothing to do with elasticity of demand.
So when the
so
predicted demand is closest to the demand that we have
Oh,
already.
brilliant. Okay, great. Yeah, yes,
so
Ravi. Yes.
we can plot a line chart with respect to linear, exponential, and power, and check that.
Okay. Essentially, what Ravi is saying is, look for how closely each model actually, how best it predicts what is actually happening out there. That's what Ravi said, right? Just try to see.
So the residuals.
We can also use R square value, right? Because it is already in the trend line option.
No, but I don't know. See, R square concept. I will bring in the R square concept, Kiran. It's not It's not actually relevant in this example. Okay. Yes, Puneet is trying to say something. I take your point, Kiran. We'll come to your R square thing. Okay. Maybe next session we'll talk about R square, the relevance of R square, but not in this. Yeah, Puneet. Yeah. Yes, Puneet.
Sir, I would calculate profit from using each of these models and then see which one is the maximum profit, and then.
No, but if a model is wrong in the first place, but if we are actually using the wrong model to calculate the profit, we're trying to see optimize which is the best model. If you use the wrong model and if you get inflated profits, how is that going to help?
So we will check the residuals. The minimum residual is the best model.
Absolutely. So we're going to look at the errors. Okay, we'll try to see how much our calculated or estimated value is varying from the actual demand which is out there. We know the actual demand for a particular price point, and we have this prediction from 3 different models. So there is an actual demand, there is a predicted demand, or there is an estimated demand. So let's compare and look at how much each of those is varying from the actual demand out there. Okay, let's do that exercise now. Okay, so this is the linear model. With the linear model, the demand is estimated to be 51.7. However, in reality, the demand is only 45. That is 4500. Okay, this is predicting it to be 5100. That is 5170. That is, so there is an error here. There is a difference. Let's calculate that error. Let's see what the difference is. That difference is actually equal to this minus this. This is the error. Okay, I can simply drag it down, and for each of these there is an error. Okay, so let me also create some space here, because I think we might need. Okay, I'll rearrange this side. Okay, let's remove. We don't require graphs anymore. These plots can be conveniently tucked away elsewhere. Right. Get it out of there.
So you can click Control and move that.
Control. No, it should move simply. Okay. Okay, it's moved. Control and move. So. Okay. Okay, I've moved it out. Okay, because I wanted some space here. Now this is exponential model. Let me create some space, and I say insert cells, shift cells, right? That's okay. Again, some more insert cells, right? Okay. This is the power model actually. model here. Okay. All right. So similarly, I want some space here also. Insert. Right. Okay. Insert. Right. Okay. This is a power model. Okay, fine. So now for the linear model, what I've done is this is the value predicted, and this is the actual demand is 4,500, but however we have predicted 51,700. So we have tried to find the difference between the linear model and the actual demand. So which is simply this value minus that value, drag it all the way down. Now, similarly, I can repeat the same exercise for the other things also. Exponential model, this is the predicted value, this is the actual demand, and let me pull it down. Okay, same thing for this is the error. This is what Cyan is calling as residual difference. Okay, so this is the residual or the error value. Now what? Now which is a better model? We have the yes sign, or maybe even others can pitch in. We have the error values. How do we know which is a better model now?
The power model.
No, how? Why do you say it's power is the better model?
Sir, because I took the sum of the squares of all the residuals and compared them, and the lowest value that I get is from power model.
Okay, what is that lowest value?
Lowest value would be 294.02.
You took the sum of the residuals and you picked up the lowest value, is it?
Sum of square of residuals, because there is a potential of negative and positive values to cancel out each other. Okay. So I took this square of each of these values and took the sum of them for the proper comparison between.
Okay, great. Yeah. Okay. That's nice. Okay, essentially he's trying to say that he wants to eliminate the probability of the positives and the negatives cancelling out. So he has taken the square of it and he has summed it up and looked at the lowest value, and he's estimated which of those is the lowest, and then he says the one with the lowest value he says is the power model, and he's gone with the power model as the best fit. Okay, so very sound argument, and I suppose that is correct also, but let me give you a much simpler method. Okay, so this is the linear model, and because he said there is an issue with the positives cancelling out the, so let's call this the error. Okay, now we need to sort of ensure that the positives don't cancel out the negatives, so let's calculate the absolute error. Nothing but the absolute value of this. So I would use the function ABS, and okay. Now, so this is the absolute error. This is the deviation from what the actual value is. Now I calculate what is called as a percentage error. Which is nothing but the difference, that is this value divided by the actual demand multiplied by 100. Or I can just simply put it as this, and I can say percentage. And I can increase the decimal to this. Okay, I can show the exact percentage if I want to. Okay, so I hope you saw what I did. Essentially, I took the error, then I found the absolute error. I found the absolute error because otherwise you will find the positives cancelling out the negatives, which I don't want. So error, and then the absolute error, and then I find the percentage error. Percentage error is nothing but the error divided by the actual value multiplied by 100. Okay, I repeat this for the other models also. Here I'm going to do this in a single go. This is the value, and let me find the error. I find the absolute value of this. Let's say absolute value of this divided by the actual demand. And this I convert into percentage and I pull it down. This is the percentage error. The percentage error for the exponential model. Similarly, I should find let's find percentage error here. Which is absolute value of this term divided by our actual demand. Enter, drag it down, and then percentage. All right. Okay. So I have found the percentage error for each of those individual values. Okay. Now the best one would be to find the minimum. I would find what is called as the mean absolute percentage error, which is nothing but the average of this. Okay. And I use a function average is equal to a average, and okay, and this is important. Okay, I simply control C and I do control V. I see control V here as well. You can see the magic of cell referencing. You notice this is actually average of this, and I told you the formula and formatting gets copied. So I have the percentage error again for this. So what is called as MAPE, mean absolute percentage error. Okay, so nothing but average, that is a mean, percentage error, mean, absolute, because the negatives and the positives cancel out, so we need to take the absolute value, and the percentage error, MAPE, or the mean absolute percentage error of these three different models. Now the decision should be fairly simple. Which is the best model?
Power model.
Power. Clearly the power model, because that is the least. I hope all of you are able to do this simultaneously. Or do you need more time? I think, yeah, people are still busy doing this, figuring this how to do it. Yeah, Shivam has done it. So this is exactly what Ravi said. The power model is the best model. He also used the same logic, which is correct, but I've given you a simple method. Essentially, this is a standard term, mean absolute percentage error. And the same thing that Ravi said, square the errors, and then sum it up, look for the least one. That method also works. Yeah, I see Aditya is also comfortable. Kiran is also comfortable. So far what we have done is, we have, so where is Satyam? Satyam is okay. I think she was struggling initially. Satyam, you're okay? Yeah, Monu, Puneet. Yes, Puneet had something to ask. Yes, Puneet.
Sir, in this case, we have taken the average of percentages over different ranges. Like, for example, the denominator for 2.73 percentage is different from 108.5.
No, denominator is the same, because we are taking for the same forecasted, same original value of demand.
Yeah, but that the denominator is different for each of the rows. So is it okay to take an average of percentage when that percentage has been taken for different?
We're looking at the percentage. See, denominator is the same, right? Every time the denominator is demand. See the red cell?
Yeah, but that is different for each of the rows. Like from 22 to 33, all the demands are different.
That's okay. But then we are, this is an apple to apple comparison, right? Everywhere we are actually, see, error in the first instance, error in the second instance, error in the third instance. We're trying to minimize the error. And that is the reason the percentage part is important. What percentage is deviating from the actual demand? Somebody's put something on the chat board. I'm doing it. Okay, Satyam is doing it. Okay, fine. Yeah. Yeah. Sorry, Puneet, does that explain it, or you're still not sure?
Sir, I think in the case of financial metrics, we don't do that, because that, like, for example, this is, if I have to just give a financial analogy, let us say each of these 450, 300, 440, these are companies' revenues in different time periods. Quarter 1, quarter 2, a month 1, month 2, whichever. Okay. So we don't take average for this entire thing if we are comparing it like this, because it's not giving over the entire period. These are like discrete values. And if I try to use calculus over it, and if I try to minimize or maximize, it's not the same function. Maybe we can take it offline. It's slightly a different.
So that's what I don't want you to end up confusing the others. So maybe we'll talk about it maybe 15 minutes after the session, whatever, after the session, we'll talk about it, right? But essentially, what we're trying to do is the percentage error for each value, forecasted value, that should be minimized. And then when we look at all the percentage errors, we're looking at picking up the one which is the minimum. This is a standard method used, which is called MAPE, mean absolute percentage error. Absolute value because you don't want the percentage and negative to cancel out. The percentage because you want to see how much that relative to the value which is calculated, and then of course the sum of all those errors, and you take the average. The one which is, this is also the same answer. If you do what the Ravi said, you will also get the same answer. You will come to the same conclusion that the power model is the best. Okay, and again coming back to Cyan, I think Cyan should be surprised from, because he was saying exponential model would be better, but like so power turns out to be even better. Okay, even better.
Quadratic would be much better.
Okay, we could try that also. We could again take quadratic and try again. But okay, yeah, let's say in the interest of time, let's move forward. Maybe in the next example, we can also try quadratic.
Sir, should we check the average of all this percentage error, or because you can take the means if you check for month 1, exponential model is best fit for month 1. Okay. So should we check for average, or we should go for monthly wise?
No, that is the reason we are saying we should always look for the that's the reason we are taking mean absolute percentage error, and that's the reason we are summing up. No, let's say for instance, if for the first month exponential model is best, let's say for the 9th month it is the worst.
Yes.
14.9. Correct. So again, let's say if you look at the 9th month.
But if you check from month 1 to 4, exponential model is much better.
Correct. But let's say there are other months. If you look at, let's say, month 7, in the error is 1.4% only in the other model.
Yes.
If you look at 10, it is only 3 against 8.5.
But I think that would depend only if the question says that are we trying to find the percentage error or the percentage error only on the monthly basis.
Yeah, but that's the reason we're doing the average. So we try to see, optimize, try to find the minimum, when you add everything, the average. That is, find the average and find the minimum. Right. In some months, some of them are fitting closer, and the other ones are a better fit, and all, and so on and so forth. So let's find the average and then pick up the one which is minimum, which actually minimizes the error. And we also get the closest switch. All right. Okay, so if now we have this as our best fit power model, let's go forward. Now we only see the company wants to estimate the relationship between demand and price and then use this estimated relationship. Now we only establish the relationship. So we understand there is a power relationship between price and demand. Okay, and assuming, and first now we've established the relationship, and based on this we have to answer the question, assuming the unit cost of producing a set of clubs is $250 and the price must be a multiple of 10. What price should the company charge to maximize its profit? So let's just put down the givens once again. So demand, price, okay, Demand, we don't know what the demand is. We don't know what the price is. Okay. Unit cost is $250. Let's see. $250. Okay, and let's say dollar. Okay, unit cost is $250. Demand, we don't know. Price, we don't know. What else do we know? And the price must be a multiple of 10. Okay, price should be a multiple of 10. Okay, I'm formatting it so that, okay, right. So our objective is, what price should the company charge to maximize its profit? Okay, what should you, so let's say this is your profit. We don't know what the profit is. That will be revenue minus cost, total cost. Okay, so profit is nothing but revenue minus cost. Okay. Now, what is the total cost? The total cost is going to be unit cost multiplied by the number of units which you actually wait, yeah, multiplied by the demand, sorry, yeah. Okay, so we don't know the demand as yet, so let's say, let us now estimate the demand using our best fit model. Okay, so the best fit model, it is a power model. Using this, we will be able to estimate our demand, which is this. We choose a power model. So let us say unit cost is 250. If the unit cost is 250, it is unlikely that we will sell it for less than the unit cost. Okay, so let us say you cannot sell it for 250, you will go to sell it for something larger. Let's say price is going to be 260. 260. Let's say the price is 260. If the price is 260, what is going to be a demand? And that demand we are going to get from our model. That is going to be y is equal to ax raised to b. That is a value we pick up from here multiplied by x. X here is the price raised to b. And let me lock in these values here. F4, F4. Okay, so if the price is 260, your demand is 143.2576 units, or rather the demand is in thousands. Okay, zeros in thousands. Clear about it. I'm pulling this down, making a little bit of space there. The actual demand actually be this value multiplied by it's not thousands, it's 100 multiplied in hundreds. So it will be 143.25 because it is number of clubs We'll kill the decimals. Okay, so actual demand is going to be 143.26 when the unit cost is 250. Okay, now if I change the unit cost to, let's say, 500, you can see, not sorry, unit cost is fixed.
Sorry, price 250 you assume or it is given?
No. Price is a variable. No, say 260. See, why did I put it 260? Because your unit cost is 250. If the unit cost is 250, will you sell it for less than 250?
No.
Right, and it is also saying in multiples of 10 or in addition of 10. That is what the question is saying. So I'm just saying, if you sell it for, if your unit cost is 250, you will be selling it for $10 more minimum. Correct? That's our initial estimate.
Okay.
Let me put it as dollars. Okay, yeah. Okay. So price is $260. Now, if the price is 260, your demand is going to be 14326 units. Again, if I change 260 and if I make it, let's say 300, you will notice your demand is shifting. Okay. Again, if I make it 500, if I change my price, again, demand comes down, actual demand comes down. Okay. So this part is okay. Now for every price, we know what the demand is going to be. And this we are picking up from the power model, which we find to be the better of three models we have tried to compare. Okay. So far, I suppose all of you are comfortable. Now let's move on. Let's look at the total cost. So now if you're ordering, let's say for instance, let's say if your actual demand is 4109, okay, the total cost is 4109 multiplied by the unit cost. Okay, the cost is, total cost is going to be the demand multiplied by the cost per club or per set rather. Okay, so that is going to be this much, 10,27,000. I'll kill the decimals here. Okay, it's going to be 10,27,127. Now, what is going to be revenue? Revenue is going to be your price. You're going to sell, your demand is going to be for 4,109, and that multiplied by the price at which you're going to sell it, which is this unit here, 500. Okay, again, let me kill the decimals. Okay, and the profit is actually,
sorry, the last step, can you elaborate once again?
Okay, yeah.
The revenue part.
Yeah, revenue is nothing but, see, you set the price at 500, correct?
Right.
And you are selling demand, you're selling 4,109. Number of units sold multiplied by the price at which you're selling it. That's the revenue you're generating. Price into quantity.
Got it. Okay.
Okay. Cost similarly is the quantity multiplied by the unit price. Same thing. Actual demand 4109 multiplied by the unit cost. Okay. I've highlighted the cells. Okay. And the profit is, I'm just copying the format here. Okay. So this is the price. This is the profit. So you can vary, you can see that every time I'm changing the price, let's say 267. Okay, I'm not allowed to do that. I have to take multiples of 280. You find that the whole thing changes. Okay, the demand changes, the total cost varies, the revenue varies, profit varies, and so on and so forth. Okay, so now the question is, assuming the unit cost of producing a set of clubs is $250 and the price must be a multiple of $10, what price should the company charge to maximize its profit? So now, the simple argument would be, let's say, for instance, sell as much as you can. Okay, so let's say, for instance, sell at the highest price that you possibly can. So you notice that when I'm giving a value of 280 here, I'm making a total profit of, let's say, 3,73,049. So what if I increase the price to 600? It is going to 10,15,000. Okay, what if I increase the price to 1,200? It is actually dropping down. Earlier we had 10 lakh something. Now when the price is increased to 1,200, you in fact see that the profit has come down. Okay, so see, if I price it at $1,000, you find that it is around profits is around 8,19,932 and so on. So somewhere you notice that if you increase the price beyond a certain point, your profits actually come down. That is because the demand demanded and the quantity demanded actually comes down. There is an inverse relationship between price and demand. Okay, so you cannot increase your price sort of, it's not like the highest price you charge and the most profits you make. No, there is a sweet spot somewhere which actually optimizes your profit. Okay, let's say it could be 750. So we don't know. I mean, this trial and error thing, okay, 750, it's come to 9,46,000. Let's say 600, it's going above 10 lakh. So it's somewhere in that range, around the 600 range, hopefully. Okay, let's see how we can figure out what that exact amount is. Okay, for that we use a what if analysis. Okay, now what happens is, now for every price change I need to capture the value of profit. So you notice that every time, one way to do it is sit and then calculate for each, what happens when it is 250, what happens is 260, what happens is 270, 280, 290, plug those values here, and then note down the value of profit and then sort of make that comparison. But the other way, of course, is to make Excel do this job, and let us try doing that. Okay, so we're trying to say vary the price all the way from $250 $260, because 250 is your cost price, so you can't sell below your cost price. This is your unit price, you can't sell below that. Increment of 10, 260. Let's drag it down and say I am taking it down to, let's say, around 680, or let's say even say 810. Okay, so this is your the various prices which you could possibly charge. Okay, so I'm just putting that value here so that I don't get confused with this. So this is the price. So I need to know for this price, okay, this price, what is likely to be the revenue generated. Is everyone with me? I'm not sure.
Yes, sir.
Yes, sir.
Yes, sir.
So, great. Okay, fine. So, okay, all I'm trying to do is we have prices all the way from 250 in multiples of 10, and we're trying to see which is the best price, which optimizes or which maximizes our profit. Okay, so I have listed all the possible prices all the way from 250 to, let's say, 810. We could actually go down further, but yeah. Now so essentially for this 250 price, I need to know what is the profit. Okay, so for that I use a what if analysis. This is a function which you have in Excel, which helps me do this very calculation. Okay, so for what I do is, initially I sort of tell Excel what is the value that I need to calculate. Okay, so this, if price is 250, what should be what is the profit? Say, let's say if the price is 250, let me put this here. If the price is actually 250, your profit is, there's no profit. See, it becomes 0. Okay, let's say if I put it as 255, there is a profit. Okay, so now you know that this is the cell, that the profit cell is what is actually returning the value. So let me tell Excel, this is where you should look for. This is what you want to be calculated. Okay, now for each of this value of 250 all the way through 880, I need to know what is the corresponding value of profit whenever I change that price. For that we use the what if analysis. So what if analysis is actually found here. We come to data. Data tab, there is a what if analysis, and there is a data table option. Okay, and then I have to tell Excel the basic inputs. Now, because my data is put in a column, okay, because my input data is put in a column, I only need to put the column input cell. Okay, so essentially I have to tell what is this column input cell. So hang on 1 second. Okay, so before I go there, I need to initially select this, select all of this, all the data. Then I go to WATF analysis and I say data table, and I need to tell in Excel the column input cell. The column input is the price. Okay, so it is here, that is B48. I click on OK, and Excel automatically fills up the formula for me, all the values for me. Okay, and this is the profit value. This is price and this is profit. Is that okay? I have a feeling that you must have done this. Yeah, you must have.
What is the use of, yes.
Yeah, please go ahead. Yeah, Sayan, tell me.
So what is the use of H44?
Wait. Let me just.
This 74335.
Yeah, this one, right? 74335, correct?
Yes.
See, it is with the help of this that Excel is calculating the remaining value. This 74335 is actually cell reference of this particular number. See, if I change this here, let's say I put it as 300.
Okay, I got it. Yes, sir. Yes.
300. Okay, that changes. It's not a fixed value. Essentially, Excel is using this function to calculate. See, there is a relationship between this 544, 986 and 300. So it is establishing that same relationship between 250 and 260 and 270 and all those values. That is what it is trying to do. Is that okay, Sayan?
Yes.
Others, I would.
This what if? Can you please show it again?
Yeah, sure. It is a little confusing. I'll have to show it 3 times. So it's okay. I understand. Okay. So essentially, I'm going to. Yeah. Okay. So I'm going to delete the whole thing first of all. Okay. So I hope you get this particular column that I have stacked here. Essentially, it is all the price points for which you want to find the profit. Ultimately, what is it that you want to do? We want to see which price point gives you maximum profits. Okay, we want to look for that maximization of that. Now, therefore, I have looked at all the input values. So I know that the price has to be about your cost price. Cost price is 250. So, okay, I put 250 here. That will give you a 0, but it won't give me a profit. But anyway, price from 260 onwards, I have taken values all the way to say 810. That part is okay, Aditya? Okay, why I have listed this? Yeah, okay, fine. So that okay. So price is here. Now, for when the price is 250, I need to have a certain value of revenue or profit. Sorry. Okay. Similarly, for 260, there has to be a certain value of profit. For 280, there has to be a certain value of profit. So as the first step, what I do is I have to tell Excel what is this. For 250, there has to be some corresponding value, right? So what I do is I need to tell Excel that value first. So I put an equal to and I cell reference that particular cell. So I click on this because it is profit that I want to maximize or profit which I want to figure out. For the value of price, I need to figure out some value. What is that some value which I'm trying to figure out? It is a value of profit. So I click on that and I tell Excel, this is the cell reference. This is what you should be looking for. And I click on enter. Okay. I don't need it, but Excel needs this. Okay. So now maybe I can gray it out. Okay. I will gray it out. Okay. Okay. So I don't need it. It is for Excel's calculation. Essentially, there is a relationship between this 300 and 544. I want that same relationship to be, I want Excel to determine that relationship which is there between 300 and 544 to be established between 250, 260, 270, 280, 290, and so on and so forth. Okay, which is for me the value of profit. To do that, what I do is I select all the cells. First step is select all of this. Click on this. Control Shift down. Okay. Then I go to Data tab. go to what if analysis, and I go to data table option. Okay, this is essentially trying to retrieve for each value in this particular column. It will retrieve the corresponding value of profit. Okay, but I need to, so I have this already arranged. Okay, I have this table already set up. Now I need to tell Excel to obtain 544,986. Okay, that has come by changing the value of price. Okay, so that is why I have to point out that to Excel, that by changing this value of price, I have got 544,986 profit. Now in the table here, I have all the values from 250, 260, 270 and all the way till 800. So that is already known to Excel. I have listed all those values and I've highlighted it. So Excel now knows that you have to establish the relationship between 300 and 544,986 and same relationship between 250 and some other value. And Excel will populate that value on its own. And that is what the data table function does. Okay, let me click on OK. And it has given me the values. So let's try that. See, 250 should be 0 naturally. 260, let me plug in the value here, 260, and that is 14325. Okay, so that, let me just format this. Excel may not allow me to format the table. Let me try. Wait, it won't allow me to kill the decimal. Oh, it does. Okay, okay, great. Okay, yeah. So you can see this value 143,258 for let's say 260. So when I say 280, the value is 373049, 373049. Correct, this value. Okay, so essentially this particular function is auto-populating all of these values. What I should have otherwise determined by trial and error method, in one shot, Excel is telling me for various price points what is likely to be the profit. Is that okay? Yeah, Aditya, is that okay? Please try it yourself.
Yes, yes, I'm able to do that.
Yeah, please try, all of you try this yourself. It's a little tricky. I can explain this once again. And if you have got it, please give me a thumbs up. Okay, Mono's okay. Okay, Sayan, Srivatsam, Deepak, Suvam, Deepak, Anshri, Om, Shivam. Okay, Kiran. Ravi is still working on it. Okay, fine. Okay, I think all of you must also got it. Okay, fine. So now let's look at this relation between price and profit. So I am picking up these values and I'm plotting it. I'm saying insert, I'm saying chart, and okay, I'm picking up this chart. Okay, so this is essentially the price versus demand curve. So you notice that it goes up and it curves down, and somewhere you have a sweet spot somewhere here, I suppose somewhere here, because after a point the price begins to, the profits begin to drop. Okay, so one way we can do that is determine that is use the conditional formatting function of Excel, which is select all the cells here, Control Shift down, go to conditional formatting on the home tab, and then say color scale, or maybe okay, I can use top bottom rules, top 10 items, and I say fill top cell, fill with green.
So we can even use max function.
You can, of course, okay, but you will appreciate this is about, see, look at this visually, you can see this is the value which, so if you've set the price as 520, you actually maximize your profit. Of course, you can use the max function, you can pick it up, but like, no, this is more visual and it just hits you. 520.
So maybe you can also use the rank function also.
Yeah, absolutely, you can use the rank function also. Totally, right? Now, if you notice, Now, this is true when the unit cost is 250. This particular thing is true. Suppose your unit cost goes up and it becomes 300. You see everything automatically updates, and you see if the unit price is 300, then your optimized value is actually 630. You should price it at 630. That's when your profit gets maximized. Okay. Now, if the unit price again drops down to, let's say, 280, you notice, 590 is the optimal pricing. Okay, and let's keep it at 250. And this is what it is. At 250, you should sell the product at 520, and it will give you a profit of $10,29,234. Okay, assuming unit cost producing 250 clubs, price must be multiple of 10. What price should the company? How does the optimal price depend on the unit cost? So, which is what I sort of just tried. If you change this again, the whole model adjusts, and if there is a change in input cost, it will reflect. This model will reflect it. Okay. I hope it's okay. Especially, I'm not sure about the table part. I'm happy that you picked it up because it's a little confusing. Okay. All right. Fine. Now, let's take a 10-minute break and come back. Is that okay, or do you want to continue as it is?
Break would be fine.
Yeah, break maybe 5 minutes, 10 minutes. What? How much? I mean, like
5 minutes.
5 minutes.
5 minutes. Okay, fine.
5
It
minutes.
is 7